try it my way and see if math gets a little easier. Where's my water? Okay, Brian, phone away. For what? We got scores yesterday. Okay, you guys, what is... Now, this is a derivative operator. That says find the derivative. And if you have a product of two functions, do you remember how to find that derivative? It's f times g prime. We have a quiz on Friday that'll include this, plus g times f prime, or f prime times g, it doesn't matter. Do you remember that? It's a product of any two functions. Doesn't matter. What about if I have division? Okay, so it's low d high minus high d low over the square of low we go. Now, I might have had written g over f, but it doesn't really matter. That's all you need to know to do this little sparse data worksheet. This comes from the University of Minnesota. It's very typical AP that they might give you something like this and you read things out of a table. Oh, this way. So all I know about my functions are the data that they give me. That's why it's called sparse data. There's not a lot of information there. So I want to find the derivative of e to the x times f of x. So number one. And the answers are all online. But we're going to do this. Well, I'll have you guys do it. Do you know what I have to do? Whoops, a little too much. Do you know what you have to do to find h prime? Now, you never, ever, ever put that 0 in before you take the derivative. Okay? You guys got that? Some of you want to put it in right away. And if you do, then I have e to the 0 times f of 0. That's a constant. What's the derivative of a constant? 0. So that doesn't do you any good. So you have to do the derivative first. So how do you find the derivative of that? Sure we do. It's a what? H of x is equal to e to the x. What's the operation? Right here, times f of x. So what rule? Product rule. Right? If you did the practice with the product rule, you should see it. So it's h prime of x is equal to e to the x times the derivative of f of x. Call that f prime of x. Because remember, these are just two functions. I, in particular, know that that's e to the x, but that doesn't matter. Plus, then I have f of x times the derivative of e to the x. That's the easy one. What's the derivative of that? E to the x. Haven't shown you why. Well, actually, I did it with the derivative. Now you substitute in the 0. So h prime of 0. And I have a lot of trouble putting everything in here. It's e to the 0, f prime of 0. And if you just come on the exam and you just put up an answer, even if it's right, you will get no credit. So you need to write what I'm writing down there and then show the values out of the table. Even if you write that and come up with an answer, I don't think you're going to get full credit. They want to see you read the numbers out of the table. Well, this is 1. What's f prime of 0? F prime of 0 is 9. Plus f of 0, I got to read it out of the table, 5, times 1, which is 14. Is that okay? There's a lot of confusion last hour. Okay, Jack, is that okay? I like that. I got 3 for the price of 1. So everybody has problems with number 2, and I don't know why. Now, there is, and it's in your homework, what is the derivative? Remember, that just says find the derivative of some constant. That's a number, not x. X is not a constant. x is a variable, times f of x. Well, if we use the product rule, we would do this, right? You go k times the derivative of f of x, which is f prime of x, plus, and ask, how did I get what? 9? F prime of 0 is 9. Look in the table. Okay, sorry. So it's k times f prime of x plus f of x times the derivative of my constant. What's the derivative of k? 0. So this term goes away. So this really is just k times f prime of x. So what you can do is take a constant, not a variable, and pull it outside the operator. So when I do problem 2, I can ignore the negative 4. It's still there. I'm going to do the derivative of f times g and multiply my answer by negative 4. So let's get a plan here. I'll trip on it otherwise. Okay, so you take the derivative with respect to x. I can just pull it right through that constant. By the way, that is the answer to one of the homework problems. It says show that you can pull that constant through there. I don't know which one it is. So j prime of x is equal to a negative 4. Now it's just product rule. So it's f times the derivative of the second one, which is g prime, plus g times f prime. Why don't you try that and see if you can get the answer? Okay, so this is negative 4. F is what? That's negative 3? I'm going to trust you. It's 3. What's g prime? Plus. Remember, it's negative 4 times that. What's g? Negative 48. What's g of 1? And f prime of 1 is? Negative 3. So I get 18 minus 6. So it's equal to negative 4 times 18 minus 6 is 12. Okay. Okay, you ready for number 3? Casey, we're going to make a plan for this. So I'm going to go on another page. X, f of x times g of x. X times f of x over g of x. What's this function's name? It's the quotient rule, but what's this function's name? Okay. Okay. Okay, you ready? Jack, you ready? Okay. So it's to find the derivative. This is the plan. Let's call it a plan. It's the denominator, the low, times the derivative of the high. I'm not going to take the derivative yet. I'm just going to say I'm going to do it. So it's d dx of x times f of x. So that symbol means find the derivative. That's what the d dx means. It's telling you with respect to x. As we progress through the course, it'll become more and more clear as to why it looks like it does. It's Leibniz's notation. Blame him. This means find the derivative of this. Yeah. Minus the numerator, which is x times f of x, times the derivative of the denominator. I'll also call that d dx of g of x. We call that what? G prime of x. You like G prime, it's shorter, but it doesn't seem to bother you like the d dx. Just means take the derivative, like a plus sign means add. A square root sign means find the number that you multiply by itself twice to get that number. You can make any symbol you want. Another symbol would be this. Take the derivative with respect to x. It's an operator. You should have seen that on the SAT. Well, I would think. All over Don't tell me. You're not supposed to tell me. G of x, what? Squared. Okay, I haven't taken any derivatives. I've just used the quotient rule. Well, sort of. I'm sort of partway through it. Now, this is the part that bothered everybody today. What rule do we have to use? Product. You can't put x in there yet, can we? Remember I said never, ever. Okay, Zach, you got this? It's g of x times. Now let's use that. Ben, what's the answer going to be? What's the derivative of x times f of x? What? No. What is the derivative of this? It's x times the derivative of f, which is f prime of x, right? Yeah. Oh, no, we're not going to put numbers in yet. Let's get the plan. Plus f of x times the derivative of x. Do you see why you have to use the product rule? The product rule is a product of two functions. Even if this was a constant, you could still write it out like that, then the derivative of that constant would be 0. In this case, it's not 0. It's what? It's 1, isn't it? What's the slope of that? What's the slope of y equals x? Oh, yeah, this, all I've done right now is this piece. Oh, yeah, it's long. I'm not done. That's just that piece right there. The yellow parts match. No, it's not a constant. X isn't a constant. Y equals x. That's a variable. X could be 1, x could be 2, x could be 3. It's changing. Because it's x. It's not a number. Constants must be numbers. It represents any number. It's a variable. Well, so does f of x, too. So you can say they're both constants. They're not constants. I haven't finished. Oh, it's right over here. Minus f of x times the derivative of g. What's the derivative of x? Well, you could do 1 times 1, x to the 0. That rule has to work. It does. Because you don't want to do two things in one problem. You also want to think, guys, you want to think that x is a constant. It isn't. It's some function of x. Turns out I know what the function is. I don't know what f of x is. F of x could be x cubed for all I know. I don't know. And I'm not done. All over, and we get the denominator right usually, g of x squared. Yeah. After you take all the derivatives and get all that done, now you can put the numbers in. But never until you're done taking the derivative. That's long. But you know what? If you're going to become an engineer or a scientist or even in accounting, you're going to have long things like this. It's just the way it is. Accounting. Oh, accounting, you have to account for everything to the penny. So I never balance my checkbook anymore. I just look at my bank statement and said, okay, I got enough money. It's fine. Because I could never get it down to the penny. I'd be off by 3 cents. Yeah, it's not as bad as my mom. She balanced it by hand, and then she took a calculator and balanced it. She got the same answer, but it was wrong. How do you get the same answer but being wrong? Same answer being correct, yes. She was just wrong. So she didn't understand the concept of adding, subtracting. Okay, why are we evaluating this? At -2, is it? Where are we doing this? -2. It's just -2, right? This is a function. X is a function. I mean, it's y equals x. I don't know what f of x is, or g of x, so it doesn't really matter. So it's g of -2. I'm going to put these kind of parentheses in there. Let's do the derivative in a different color. That's negative 2 times f prime of negative 2 plus f of negative 2 times the derivative of x, which is just 1. I didn't need that, but I chose to put it in there. Minus a negative 2 times f of negative 2 times the derivative of g, which is g prime of negative 2, isn't it? All over g of negative 2 squared. And then you use the chart. Oh, there are lots of places to make mistakes. But we are not going to make a mistake, right? What's g of negative 2? What's g of negative 2? Negative 5? I think you're supposed to get 43 over 25. Well, negative 2. What's f prime of negative 2? Because I'm going to do it because not everybody's going to get it. That 1 plus f of negative 2. Is that 3? It's actually scary why I knew that. Okay, 2 negatives make a positive. What's f of negative 2? That was. How do you get rid of the x? What is x? Negative 2. It's k prime of x. X is negative 2. That's x. And so it's negative 2, or so it's 2. I fixed the sign. And f of negative 2 was 3. What's g prime of negative 2? That one I don't know. Is it 8? Okay, I'm just trusting you guys. Now, when you do this, either you just square it, or if you're going to substitute it in, you must have parentheses. Otherwise, it's wrong. It's negative 5 squared. This negative 5 squared is a negative 25. And that's not the right answer. It's positive 25. Okay. And now we just do the arithmetic. Now, I might give this to, we're doing order of operations in my algebra class. So maybe I'll give this to them. So it's negative 5 times what? No, 3 minus 2 is 1. 6 times 8 is 48, all over 25. There you go, 43 out of 25. I did. Negative 2 times 1. No, because the negative 5 only operates on this part right there. Notice the use of vocabulary, operates. That's a multiplication operator. A derivative is an operator. It's just a new one. You could make up your own operation. In fact, I've seen it on the SAT. But wait, that was way back. Way back. I don't know if they do that anymore. I would think they do. Okay, we ready for the last one? Now, the last one bothered everybody because just guess what? We have 3 functions multiplied together. Was it negative 43 over 25? Okay. So is that positive? Okay. Now, I don't care how we group it. Now, we may want to group it a little differently than the other class so they have 2 different solutions, but they're both the same. Either you got the product rule twice now, don't you? Because it's this. L of x is equal to x cubed times f of x times g of x. So we have to group it. You want to group the x cubed and f of x together or the f and g together? I don't care. We did f and g in the other class. Which one? Are these guys? Okay. Pretend that is just some other function. Call it z. How do you find the derivative of this product? It's the first times the derivative of the second plus the second times the derivative of whatever's in there. Call it z. So here's the plan. Whoops, I don't always read. I always like to have a plan. L prime of x is equal to x cubed times f of x times the derivative of g. What's the derivative of g? G prime of x, right? Plus, then it's g of x times the derivative with respect to x of this thing right here. X cubed times f of x. Now, x cubed is a function. Do you have to use the product rule? It's not a constant. It's x cubed. Depends on what it is. Okay, so I'm just going to rewrite this. This is going to be x cubed f of x times g prime of x plus g of x. Okay, now we got to do the derivative of this. Okay, so somebody said the derivative of the first one, which is 3x squared times f of x. Okay. It's okay. It's x cubed times, it's the derivative of x cubed times f plus, remember it's the product rule. You can't take the derivative of x cubed times the derivative of f. I wish you could. It would be so much easier. Oh, I know there's not enough space, but you can't. So it's plus, and then we leave the x cubed alone, and we do the derivative of f. Because it's the product rule. Just because you don't like it doesn't mean we don't do it.
From the product rule we learned from before, we plug this into that.
Yeah, it's a plain old product. I have to do the product rule twice.
Can you use a different equation? Which ones did you use the product rule?
Anytime it said product. Right here. That says times. Product rule is times. So if you have two functions multiplying, and it works with constants. But what's the derivative of a constant? Should I do that again with the case? You got it? Because that's what's happening. Okay. Looks ugly. And where are we evaluating this at? 2? Negative 2? I don't have, you guys took all my handouts. Is it 2? L prime of 2? Well, let's go ahead now and put the 2 in. So that's 8, right? What? What is g prime of 2? That's what we're going to try and find out. Let's just go ahead and put let's put the 2's in first, then you'll see what happens. Then this is g prime of 2, which we're going to call z because that's our unknown, plus g of 2, because it's 2 cubed. Can I go ahead and put the 2 in here? What's 3 times 2 squared? 12 times f of 2. I just think it's a little easier to read. It's 3 times 2 squared. You have to square first, then multiply by 3, right? Plus, then what's this going to be? 8 f prime of 2. And then we substitute in what we know. Because it says, what is g prime of 2? This is what I don't know. It's not in the table, is it? Nope. That's what they want you to find. But, you know, it's just an equation. What's L prime of 2? I forgot. Negative 48. So, yeah, you're doing the whole thing. Okay, that's 8. What's F of 2? Negative 5, right? Is that right? Times, you want to call it g prime of 2 or do you want to call it z? Okay. How about if I do it in a different color, though? What's g of 2? 8. That's 12 times f of 2. Negative 5. Plus 8 times what's f prime of 2? Because this is where the mistake's going to be. Okay, Brian, what's this answer? 3. You guys, you can do all that later. Okay. Forget I don't go home with you. Okay, so negative 48 Actually, I kind of want to factor on an 8, but that might bother you. So we'll just do the arithmetic. This is negative 40, g prime of 2, right? Plus, and let's see, it's 8 times, that's negative 60 plus 24. Where did I get negative 48? It gave it to me. Right in the very beginning. Because I'm sure there's somebody else going to have a question on that. Whoops, did I go too far? There it is, right there. And then we just have to do arithmetic. So it's negative 48 equals negative 40 g prime plus 8 times what? Negative 36. Because that was from way up here. What's g prime? That's one we don't know. We don't know it. That's what I'm trying to find. Okay, I'm just lazy. Okay, what is 8 times 36? Minus 288, so I'll add 288. Oh, that's not too bad, is it? Is that bad? It's all arithmetic, so it's 240, right? Oh. What's g prime of 2 then? Negative 40. So g prime of 2. You just have to, now math tells you what to do. You have to follow the directions, to follow the rules. Can't break the rules, right, Riley? That's the answer, negative 6. The rule says you have products here. You have to worry about that. So I grouped them. I put these guys together, and I left it that way. It's the first times the derivative of the second plus the second times the derivative of the first. Then I had to figure out what that was. Again, it's the product rule. Now, let's do some questions out of homework. It's on your assignment sheet. Huh? It's online, too, assignment sheet. Day 2. So we should look at some questions probably from day 1. Or, sorry. Oh, the one above it? Oh, that's on another slide here. It's complicated. Which 2? There's a lot of 2's. Two negatives made a positive. We still have we have about 15 minutes. We can get some problems done. So we are going to do 3.5. 3.6 looks tough. 3.6 is the physics. So it is tough. Now we did 13 in the other class on page 170. Do you guys need it? Okay, Riley should have your homework out. If you haven't done it, we should start it. Do you want to look at number, because we haven't done a problem like 13 in a while. Yes, no? Should we start with the first problem, which I don't know what it is? Page 170, it's 3.5, day 1. What's the first problem? It's page 170. Number 7. 7 through 31 odd. And we gave you the odds so you can check answers in the back, but the solutions are online. Okay, number 7. We've done this problem before. Ben, do you remember it? It's 170. It's page 170. Okay, phones away, please. Guys, that's the only time we have. You could do that later. Do you remember what this limit is? 1. Okay? Declan, do you remember this?
So the answer's 3.
Because you have to show the work. So these have to match. You can't pull the 3 out because that's wrong. So I'm going to put a 3 there. Let's see. And then I'm going to, if I put a 3 there, I'm going to put a 3 also in the numerator because that's equal to 1. Guys in the back, it's 3 of you. Can I pull this 3 out of here? Yeah. Can I pull that 3? No. That one you can pull out. And we know what that limit is. 1. Okay, that was the first homework problem. Yeah, and do the easy ones first so you have confidence. Now, somebody asked me for something else. 15. Yeah, I'm kind of surprised nobody asked me about that. Now, this, I don't have a video for my other class, but I do have problem number 9 done. Well, I'm going to do a little trick here. Should we go ahead and factor this? Okay, girls, what happens when I put in 2? We haven't seen anything like this. If you remember, you always substitute, and I get the sign of 2 minus 2 over 4 minus 4. So I guess what? I get 0 over 0, right?
You mean approaching?
Yeah. Lost my little arrow. Okay, you guys. How about if I factor that denominator? All I know is that sine of x thing. I would like to get something that looks like the sine of star over star and the limit as star goes to 0. I don't care what you call it. That's 1. And I see, do you guys see it? Guys in the back? Do you see that this divides into x squared minus 4 evenly? So it's the sine of x minus 2. And then this is x minus 2 times 1 over x plus 2. I'm going to write it that way because it's a little easier to see. All this is a shift 2 units away. So this is 1, isn't it? Yep, it matches. So I really have this limit, if you think about it. It's the main limit theorem says I may do this, provided that each limit exists times the limit as x approaches 2. I'm doing it the long way, over 1 over x plus 2. Yep. But that's what I'm doing. So this is 1, and this is 1/4. So my answer is 1/4. Does that make sense? Yeah, good. The problems are going to be all different. They're all R3s and R4s. The more you do, you can do more than what we assign if you are one that needs more practice. It's a minimum assignment that we're giving you. In fact, it may be a little bit bigger than that. So what about problem number 19? Now, I do have little signs for my room. Oh, we all do it. Mr. Diamond doesn't. So let's do number 19. So by May, you've got to know all these derivatives because I leave it up all year, but they make me take it down for the exam because it's against the rules. Can't have anything math related. Pardon? In here with all the stuff on the walls? Yeah, I just haven't gotten into it. So I may come in here tonight and put them up. Okay, ready? How do we do this one? This is f, and that's g. It's just two functions. Okay, so you know how to do it? It's the first times the derivative of the second. What's the derivative of sine? Cosine. Plus, then it's the sine of x times the derivative of e to the minus x. Well, you guys, I don't like that they threw this in here because you don't know why this is what it is, but that's an exponential. Okay, guys in the back? That is not a power. X squared is a power. 2 to the x is an exponential. And they have different rules. This is good. I have to do the derivative of e to the minus x. On one of the handouts, we have the derivative of e to the kx. They tell you it's e to the kx, and we put a k down here. And they don't tell you why. We will get to that after the next test. It's called the chain rule. So I don't like the fact that they put it in here. Why not just make it e to the x? You still get the same practice. So what's the derivative of e to the minus x? Well, it's e to the minus x, and it's times that constant in front of x, which is a negative 1. Good enough by me. They might factor out e to the minus x, but I don't care. Yeah. The only thing they're going to do is have trig identities. Now, we're going to do number 23. 21 is the product rule. Do we have time? Because this one can be simplified. Now, if it's free response, I would not simplify it after I'm done. I wouldn't do that. But if it's multiple choice, because this is doable, I might have to simplify that. So how are we going to do this? Y prime equals the denominator, slow, sine of x plus 1, times the derivative of the numerator. Whoops. What's the derivative of cosine? Guys, what's the derivative of cosine? Negative sine of x. Remember, all the cofunctions, their derivatives are negative. It really helps to know that. Okay, Sophie, what's next? Minus the numerator times the derivative of the denominator. Cosine of x. All over this thing. Sine of x plus 1 squared. Never, ever multiply that out. You'll never see me multiply it out. So when you multiply it out, I go, why'd you do that? I never did it. Yes. What's the derivative of your constant? Yep. Those are good questions, though, because sometimes you forget. Let's simplify this. Now, if this is free response, it's good enough. If they had you evaluate this at 30 degrees, you put in 30 degrees, and you leave it. You can, except that this one's kind of nice. If it's multiple choice, that won't be the answer on the sheet, because this ends up being what? Negative sine squared of x minus sine of x minus cosine squared of x. There's an identity there. See what it is? This minus sine squared of x and minus cosine squared of x, as long as they're both the same sign, is negative 1. Do you remember that? So this is going to be, whoops, I don't like that. Negative 1 minus sine of x. Some of you may see where I'm going to go with this yet. I'm not done. You think that would be good enough, but it isn't. Because what can I factor out of the numerator? A negative 1. 1 plus the sine of x. And the denominator is the sine of x plus 1 times the sine of x plus 1. That's right, sine of x plus 1 squared. So 1 cancels out. Now I see, because I've done so many of these, that I can look ahead. It's sort of like driving. You should always know where everybody is at every moment in time. I've had people right on over on me, but because I knew where people were, I managed to avoid the accidents. It's the same thing. You want to look ahead. Don't focus just on where you are right now. You've got to be knowing what everybody else is doing. So this ends up being negative 1 over sine of x plus 1. And most people on the road, honestly, do not have a clue where anybody else is. Scary.